Welcome back, focused learners, to another absolutely critical explainer. I'm your host, your strategist, and your guide through the wild, sometimes tricky intricacies of Cambridge computer science. Today, we're zeroing in on a very specific, incredibly high-yield topic, hexadecimal representation. But listen, we aren't just going to sit here and rehash textbook theory. No way. We are totally transforming how you tackle problem solving in that pressure cooker of an exam hall so you can actually lock down those top-tier marks. Look, whether you're studying for syllabus codes 0417, 0478, 2210, or 9618, you have definitely seen questions on hex. And they usually look deceptively simple, right? Yet, year after year, Cambridge examiners note that students bleed easily avoidable marks. It's tragic. So, to figure out why, we're going to look at two hypothetical students today. First, there's Alex. Alex is the kind of student who overloads every answer with raw computer science facts, but gives literally zero analysis. Then we have Sam. Sam just rushes through everything, completely panics, and totally misses the command word requirements. Today, we're going to fix their mistakes, read the warning signs they missed, and build a master strategy that guarantees you do not fall into those exact same traps. Okay, let's dive right into our blueprint for today. We'll start with the hexadecimal challenge, then move into common exam traps. After that, we'll map out the structured solution path, dig into the 4-prompt memory rule, and finally, wrap it up with a 3-pass revision cycle. Section 1. The hexadecimal challenge, moving beyond short labels. Okay, you see, there's a fundamental truth of Cambridge computer science exams that you have to accept right now. Merely knowing the theory is not enough to get the best grades. It's just not. You might know that hexadecimal is a base 16 number system. You might even know exactly how to convert a binary nibble into a hex character in your sleep. But if that is all you write down on the paper, your mark potential is sitting at a miserable 20 or 30%. Check out this insight, drawn directly from examiner expectations. Quote, "Students do not reach the highest marks by writing short labels alone. They are expected to use precise terminology, explain processes clearly." End quote. Now this is exactly where our first student, Alex, goes completely off the rails. Alex will look at an exam question asking to evaluate the use of hexadecimal in a system, and he'll just write, "It uses numbers 0 to 9 and letters A to F. It is base 16. Boom. Done. And while that's factually true, it's nothing more than a short label. It completely ignores the command word. Examiners don't want a dictionary definition. They are hunting for deep, connected analysis. They desperately want to see you put the Peel framework into action. Point, evidence, explanation, link. They need you to decode that command word, apply the Peel framework, and manage your time matrix effectively. To really grasp what the examiners want, you have to look at the massive difference between an isolated fact and a connected structure. An isolated fact is just memorizing that a MAC address uses hexadecimal. A connected structure, on the other hand, is explaining why it does. Top-tier A-star answers move from simple recognition to actual applied understanding. Let's say you're applying that Peel framework. Your point might be that hex is used for MAC addresses. Okay, great. Your evidence is that a MAC address is a 48-bit identifier. Now comes the explanation. Displaying 48 ones and zeros in binary is incredibly prone to human transcription errors, whereas 12 hexadecimal characters are so much easier for a network technician to read, record, and debug. Finally, your link connects this whole thought directly back to the specific network scenario described in the question. Boom. That connected structure is exactly how those red pen marks transform into green check marks on your paper. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving on to Section 2, Common Exam Traps, the classic wrong turns. Look, to succeed and really secure those top grades, we first have to learn how to read the warning signs. We need to identify exactly where students usually drop marks so you can navigate right around them. Now, what's really fascinating about this slide is how perfectly it describes the pitfalls of our second student, Sam. Sam is always rushing. He's stressed, he's watching the clock, and he falls into literally every single one of these traps. He uses vague wording, like saying hex is faster. Stop right there. Actually, scratch that. Hex is absolutely not faster for the computer. The computer only processes binary. Hex is just easier for humans to read. It doesn't make the processor go any faster. Sam also drops marks by missing process steps, completely failing to answer in the scenario's context, naming a device without explaining how it actually works, or giving an advantage without providing a reason. If you write down that hex is better because it's shorter, you absolutely must give the reason. It reduces the chance of human error during data entry. Without the reason, the advantage is practically worthless to the examiner. And this brings us to another brutal layer of the trap, which is having crumbling theoretical foundations. So often, students confuse nearby related concepts, and it just wrecks their whole answer. They'll mix up memory and storage, or they'll get logic processing tangled up with arithmetic processing. Imagine a question asks how hexadecimal might be used in memory dumps to debug a logic processing error. A student who confuses these terms is going to write an entirely irrelevant answer and score 0. Hexadecimal is frequently used by programmers to view memory dumps, right? These are essentially snapshots of RAM at a specific frozen moment in time to hunt down errors. But if you confuse RAM, which is memory, with a hard drive, which is storage, your entire contextual explanation completely falls apart. The examiner stops reading. You have to train your brain to clearly separate and compare these foundational concepts. All right, Section 3, the structured solution path, your blueprint for top marks. So, we've seen the traps. We've watched Alex overload his paper and Sam rush into disaster. Now let's look at the core technical methodology you need to tackle any hexadecimal representation question with absolute military-like discipline. Consider this 4-step solution path your ultimate cheat code for structuring an examiner-ready response. Step 1. Identify the exact requirement. What is the command word asking you to do? Is it identify, describe, explain, or evaluate? They all demand totally different approaches. Step 2. Classify the relevant data or hardware. Are we talking about IPv6 addresses here? HTML color codes? System error messages? Figure it out. Step 3. Explain the process in a clear, logical sequence. For instance, if you're explaining how a color is represented on a screen, you must explain that 2 hex digits represent red, 2 are for green, and 2 are for blue. Step 4. Connect the explanation right back to the context. This maps perfectly onto that Peel framework we discussed earlier. If you rigidly follow these 4 steps, you are virtually guaranteeing that you hit the marking criteria. I need to talk about step 4 of that blueprint a bit more because it is absolutely crucial. Context. The exam question will almost always feature a highly specific scenario. It could be a local school system, a corporate office network, an autonomous robot navigating a warehouse, a website database, an embedded system in a microwave, or maybe a network security incident. Listen to me on this. If the question is about an autonomous robot outputting error codes and your answer starts rambling about HTML color codes on a website, you will get 0 marks for context. Even if your explanation of hex is flawless, it doesn't matter. Your explanation must remain firmly and strictly anchored inside the provided context. Context is everything. Section 4, the 4-prompt memory rule. Building reliable knowledge. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Now we're moving into a highly practical memory structure. I want to treat this segment like an interactive workshop, all right? We're going to build reliable knowledge that ensures you are actually ready to perform under the pressure of a ticking exam clock. So here is your first challenge, data scan. You have a 60-second visual countdown in your mind when you sit down in that exam hall to extract the core trend of a question. The very first foundational prompt you must be able to answer aloud to yourself is simply, what exactly is it? If the topic is hexadecimal, what is it? Think about it right now. It's a base 16 number system. It uses 16 distinct symbols, the numbers 0 to 9 and the letters A to F. And crucially, one single hexadecimal digit can represent exactly 4 binary bits, which we also call a nibble. That is the fundamental raw data you need to extract first. Challenge 2. Find the flaw. Imagine a student writes this sentence on their paper. Hexadecimal works by making the computer run code faster. You should immediately spot the glaring flaw there. Computers do not process hex. They only process binary. So how does it actually work in reality? Remember, just naming a technology is totally useless unless you can narrate the specific process of its operation. Hex works as an abstraction layer. A human programmer takes a massive, headache-inducing string of 32 binary bits, breaks it down into neat little groups of 4, and then translates each of those groups of 4 bits into a single hexadecimal character. The result? A clean 8-character hex string. It works by compressing the visual representation of the data for the human user, not for the machine. Okay, let's see how this builds into real-world application. Where is it used? In Cambridge exams, knowing the real-world application is totally non-negotiable. You need to link this concept directly to specific technologies. For example, it's used in MAC addresses to permanently identify network interfaces. It's used in IPv6 addresses because, honestly, the sheer length of a 128-bit address would be completely unreadable if we wrote it in binary. It is used in HTML color codes for web design, it's used in displaying short, precise error codes generated by an operating system, and it is used in memory dumps for system debugging. If you sit down for the exam and you can't list at least 3 of these off the top of your head, you aren't ready. And now for our final workshop challenge, speed writing. Imagine you have 30 seconds to mentally draft a perfect paragraph answering this final, absolutely critical evaluation prompt. Why is it better or worse than an alternative? This right here is where the true critical evaluation happens. This is the exact moment that separates the average, middle-of-the-pack answers from the truly outstanding ones. Why use hex instead of binary? Well, because it takes up significantly less space on the screen, because it is so much easier for a human programmer to read, write, and remember, and most importantly, because it drastically reduces the likelihood of transcription errors. Think about it. If a network engineer has to manually copy a MAC address, copying 12 hex characters is vastly safer than trying to perfectly copy 48 ones and zeros without missing a digit. Notice what we did there? We didn't just casually state an advantage. We totally justified it with a clear, practical reason. Let's hit Section 5, the 3-pass revision cycle, securing exam adaptability. So we have decoded the command words, we have rigorously applied the PEL framework, and we have safely navigated around those classic traps. Now I'm going to show you how to truly lock in this knowledge so it performs reliably under extreme pressure, integrating perfectly with your time management matrix. This layered revision style is basically your ultimate exam defense mechanism. Pass 1. Secure your key definitions and contrasts. Make absolutely sure you never ever confuse hex with binary or memory with storage. Pass 2. Rehearse worked explanations. You need to practice writing out exactly how to convert an 8-bit binary number to hex until it's pure muscle memory. But Pass 3 is the magic step. Pass 3 is what builds that crucial exam adaptability. You have to change the scenario. If you've only been practicing hex in the context of HTML website colors, force yourself right now to write a paragraph justifying its use in an embedded system's error codes. Mix the terms up. Justify your choices. This kind of mental adaptability is exactly what the examiner is desperately looking for when deciding who gets the top grade. I want you to take a mental screenshot of this table right now. Burn it into your memory. This is your final mental checklist, the ultimate summary of all our techniques, and you need to run through this right before submitting any answer in the exam hall. Did you use precise terminology? Did you explain the process step by step? Is your answer tightly anchored to the specific context of the question? Are your choices and advantages fully justified with clear reasons? Listen to me, students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. I really want to leave you with this provocative thought as we wrap things up today. When you sit down and look at a past paper question tonight, I want you to ask yourself honestly, are you just reciting isolated facts like Alex did, or are you truly solving the digital problem in front of you using a structured, powerful blueprint? Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.